All right, so we are looking to build here a virtual persona, which essentially is a chat window where you ask questions. And the goal here is to build something that's rooted, that's grounded in information within your company. This information obviously keeps changing. You have meetings every day, new call recordings keep coming in, there's customer research going on, you discover new things via support tickets, you name it. All those things are essentially sources of data. I have two buckets here. Some data is locally in a hard disk, if you will. The other is live sources and things which are constantly changing and evolving, Google Drive and so on. Now, the retrieval augmented generation pattern, and we'll look at some details around how do we implement it, what that looks like, etc. in a minute here. But overall, and on a high level really, the first step will be to move all this data, the giant body of intelligence, institutional knowledge we have, into a place that is lending itself nicely to this AI experience, into this virtual persona environment that we need to create. The very first and most important step here is to prepare the data, and that process is called vectorization. Vectorization creates what's called embeddings, and I'll show you in a minute here what those elements of data then look like. So from texts, we are going to create what's called vectors, and these are complex numeric representations which all end up in a place called a vector store. There's many options there. We'll look at a few in a minute. But the most important thing to think about here is the user's information, as in what they're looking for, all the information in the system, it's all going to be first vectorized and then be going via the vector store for a degree of what's called semantic matching, as in what's generally the theme of the question, what are they thinking about, etc. And all that information becomes relevant and pulled back into the same prompt that the user generated. And all that information together is then sent back to some of the smartest machines we have on the planet now, the large learning model. Now, this is the point I have been, I guess, underscoring even in my blog post and my writings, etc. so far, is to say, you could of course ask the question directly, but if you do, then you're depending on that specific cutoff date when this model was trained, or even if it has live access, it does not have access to this information, or there are some fine tunings, which we'll see in a minute, that can make a big difference in the kind of results you get. So that's what's going on here. And that said, let me just also very quickly show you some names that you are perhaps hearing often. For embedding, we'll use the Gemini embedding model. Many names to that, we'll see perhaps one. The vector store I'm using is Supabase. There's Pinecone, there's MongoDB, many others. The re-ranker model, as in we'll get a bunch of responses. What exactly is it that we want to sort of shortlist and use as part of our context enrichment? That's what Cohere does here. And then Gemini comes to the point of creating a final response that's sent back to the user. So all that said, let's see this in action. And what I'm showing you here is my N8N instance. N8N is a fantastic tool which allows you to pull in nodes from different services, tweak them, tune them to the needs that you have, and I will look at some of those examples. Now, before I start, I want to credit Anirudh for creating this template, and I found this on the N8N template library. Really well done, and there's a lot of sort of ongoing maintenance work also that Anirudh has thought through, which is fantastic. So thanks to him. For our use case, we are using this from a persona perspective. And what I'm showing you here is essentially the places where this whole information ingestion and then the further processing and querying works. So step one is to bring the information in. Now, I've done that already in the sense that I had a bunch of files in a folder. Now, these are files I can upload, or these are files which can be generated by different systems. For example, Gong, using a webhook, can be for every single call they have, generate a file which is going to sit here. Do you want to do that or not is an architectural choice. There is always the option of directly creating a way to plug that information into your workflow. We'll not get into that for now, but let's assume everything that you want to think about or use for your source of knowledge is sitting here as a document. Again, analyst report, a file which is coming from your document, and things along those lines. If you have live sources like a blog post, etc., those are all things which you can pull into N8N and become part of the database. So the next thing I want to show you is what the vector store looks like on the inside. So before starting to record this video, I have already moved all those files into Superbase. We'll try and see again if I can do it, but there's always a risk of breaking something because I'm hitting pretty close to the Gemini API limits, etc. On a free account here, but shouldn't be a problem to still look at the whole process end to end. What's going on here really is as and when a new file is created, some file gets updated, or for that matter, for the first very ingest that I did, I brought in all those 15 or so files, and every single file went through this process. We set some metadata indications. Those files were sort of sorted down, whether it's a binary file as in PDF or a plain text. And based on that, and this part is the most interesting one for me, you bring in a file and then you have support available to Superbase, this is the vector store, to chop the file down into chunks, which can then be analyzed and done something with embeddings, right? We saw that, what embeddings are about. And embeddings are then what is pushed into the Superbase. So you might remember this, I told you all text will get converted into vectors. What does a vector look like? Right here. So I'm sure you and I can't make sense of this, what that is, but for the whole pipeline here, this is the code that they're thinking of. So if I send a question into the system, it is converted into vectors. It is compared with the vectors here, and that's how they do what's called semantic matching and enrich the query and things along those lines. I'm told embeddings are perhaps one of the most complex mathematical problems to solve, and then it keeps getting better and more complex. So good luck to people who are working in this space, but just to show you what an embedding model looks like, there's a bunch of options. The one I've chosen here is 004, which was recommended via some similar experiments in the past. But that's something to think about here, right? Everything which is here is now available inside of this vector store, and you can see a lot of records here and information. So yeah, that's what it is. All that said, I am now going to show you the agent. So agent essentially is a node you can bring in N8N, and the agent requires what some people call a brain, so the LLM. Here we have a short-term brain, which is what was the last question asked? What are we answering right now? So some simple stuff, which is also part of the workflow here. And I'm gonna give it a shot here. I just typed hi into this thing, and as you can see, right, this was a straight and simple enough answer for the system to tackle within these elements. They did not need to go to the high density, high value vector store. And let's try something else to say, and I'm going to just go back to say, what does an integration architect most think about? I'm going to ask this question, and now you can see, it's going in that direction, and it's going to try and, yeah, there you go. So you have an answer, and they're also telling you what the source is for this answer. And what can I'm going to ask this question, what can I do to upset an integration architect? So I'm just pushing this a little bit, and let's see what it comes back with. And you can see here again how this whole thing is bouncing around. Yeah, there you go. So here's something to know. And you can see the whole sequence that they are going through, the number of tokens being used. We are not focusing on all these elements, but of course, these are again things somebody can be thinking about optimizing. And I'm gonna just ask one more question here to say, what do I need to know about an integration architect's priorities? I made a typo sort of on purpose, not really, but yeah. So let's see what answer we're gonna get. All right, here it is. So again, back into the source. So yeah, the step 3 here is, I'm going to skip this because really this is about a cleanup. There are some codes sitting here to sort of do a bit of a defragmentation on your Superbase. This is Superbase on the inside. Whatever I'm doing here is all subject to some of the limits, etc. in the system. So whichever LLM you're using in the backend, keep an eye on what that looks like. Quite a few things to learn here as you play around with this stuff. But for now, I'm using a free tier, so not hitting any boundaries which are problematic for me. So yeah, that's pretty much it. Thank you.